Welcome to this session. We have a problem on integration. X squared over 4 minus x squared raised power 3 over 2 dx. So solution of this. We start by saying that. So the denominator is 4 minus x squared raised power 3 over 2. This can be written as square root this is how we can write the denominator. So because of the presence of or because of the existence of this radical, then it tells us that this problem is testing on trigonometric substitution. So you say due to the presence of the radical then we need to do a trigonometric substitution of the type x equals to a sine theta, because this expression is of the form a squared minus x squared. Now, square root of a squared minus x squared, we relate it to the square root of 4 minus x squared. This tells us that we should pick our a as 2. So therefore, we are going to make a substitution of x equals to 2 sine theta. So therefore, we make substitution of x equals to 2 sine of theta. Now, with this, it means that the x is the same as 2 cos theta, the theta, and the square root of 4 minus x squared is the same as the square root of 4 minus, squaring this, you get 4 sine squared theta, which is square root of 4 into 1 minus sine squared theta, which is the square root of 4 cos squared theta, and that will give us 2 cos of theta. So therefore, the integral of x squared over 4 minus x squared raised power 3 over 2 dx will be the integral. Now, when if x is 2 sine theta, then squaring is 4 sine squared theta. And then this one, remember, can be written as square root of 4 minus x squared raised power 3. So because we already have the value of square root of 4x squared, then you just raise it to power 3. You'll have 2 cosine of theta raised power 3 dx. We have gotten the answer to be 2 cos theta d theta. Now, when you simplify this, we'll have the integral 4 sine squared theta. This will be 8, 2 raised power 3, and then cos cube theta times 2 cos of theta d theta. And you see in this integral, you simplify cos theta will cancel with 1 here, 2, this will be 4, 1, and then 1. So we'll have integral of now sine squared theta over cos squared theta, because only one cancelled out of these three, the theta. And this is the same as integral of tan squared theta, the theta. You know sine over cosine is theta, tan, and then if you square sine and square cos, you have to get tan squared. So the integral of tan squared of theta, the theta, is the same as the integral of, you see tan theta can be written as sec squared theta minus 1, then the theta. So this is the same as integral of sec squared theta, the theta, minus integral of 1, the theta. And you see this is a standard integral whose value is tan theta, then minus theta, then plus constant of integration, c. So this is the same as the integral of x squared over 4 minus x squared raised to power 3 over 2 dx. But you don't stop here because theta was not in the question. So we use sine theta equals to 2 to be able now we use x equals to x is equals to 2 sine theta, which means sine theta is x over 2. Draw a right angle triangle. Sine is opposite of hypotenuse. So this is what we'll have, from which tan theta, opposite of adjacent, is x over square root of 4 minus x squared. And tan theta, theta itself, if sine theta is x over 2, should be sine inverse of x over 2. So therefore, the integral of x squared over 4 minus x squared raised to power 3 over 2 dx is tan theta. We have x over square root of 4 minus x squared, and then minus theta, but theta is sine inverse of x over 2, and then you add a constant of integration. So that is how you solve that particular problem. Thank you.